Alright, hello YouTube land. This is a short video I'm creating for chemistry students for Wednesday, September the 12th. The projector still isn't working, so first thing I'm just going to ask you to do, there's two homework assignments I checked today when you came in. First one is on page 6. It was actually due a couple of days ago, but I just checked it today. So take a moment to pause the video right now and just check your answers on page 6. Okay, and once you've had a chance to check those answers on page 6, the second homework assignment that I checked today was on page 10. So this was the homework that was due last night. You should have completed after watching my previous video. So once again, take a moment, try to get it all to where you can see it in one screenshot here and focus it. So now go ahead and pause your video again and take a moment to just review your answers on your homework for page 10. Okay, so once you've had a chance to look over your couple of homework assignments, today's notes are going to be very short. We are going to come back to these scenarios on page 11 and 12. You're going to work on those 2 pages in class. So right now, flip over to page 13. We're just briefly going to fill this chart in, and I'm going to discuss some of the concepts here on the PowerPoint, but just this page is all you need to have out for the next few minutes as I go through this stuff. Okay, so again, we're on page 13. The objective today is really just to get really good at differentiating, understanding the difference between exothermic and endothermic processes. All right. So you don't have to write this down, but just kind of listen and pay attention. When we talk about chemical reactions or physical processes, any process, and we're concerned about energy, that's called thermodynamics. Okay? And whenever we're considering energy and thermodynamics, we're always going to divide the universe into 2 parts. The system, which is what we're really interested in studying, and the surroundings, which is everything else. Okay? And so you just need to understand the big picture that we have this division, which is arbitrary. We get to decide what the system and what the surroundings are. But any process, if it is exothermic, notice the direction of the flow of heat. Thermal energy in an exothermic process is going to leave your system and go into the surroundings. All right, so the total energy in the surroundings is going to go up. The energy in the system is going to go down. That's for exothermic. So if you think about like your baggie lab that you did last week, the side of the bag where you had calcium chloride pebbles and phenol red, when you combine those things, you zip the bag up and you felt that side, it felt hot. Remember, you are part of the surroundings. So when you put your hand on that part of the bag to observe it, it feels hot because heat's flowing into you as part of the surroundings. But inside the system, the total energy is actually going down. All right. In an endothermic process, notice that heat is flowing from the surroundings into the system. So in an endothermic reaction, there is an absorption of heat by the system from the surroundings. So this was the side of your baggie that had the baking soda and the phenol red. Okay, remember the baking soda powder, when you felt that side, it felt cold. Remember, you were part of the surroundings. You basically, as an outside observer, are always part of the surroundings, observing some system. So when you felt that side of the bag, it felt cold, because when you put your hand on it, heat was flowing out of your hand into the baking soda phenol system. All right, so it was absorbing energy. So remember, you as an observer always are part of the surroundings. So that, is helpful for remembering how you're going to perceive hot or cold for exo or endothermic. All right, so again, in an exothermic process, like for example, what's going on back here is a picture of combustion. When you burn some kind of a fuel, whether it's gasoline or diesel or wood or paper, it's always a highly exothermic reaction. So the system would be our fuel plus the oxygen that's burning with our fuel, right? And the surroundings would be whatever's around it, air or people or whatever, okay? And heat is always going to leave the system in an exothermic reaction and go into the surroundings, so into like the surrounding air, it'll heat it up. In an endothermic process, it's reversed again. Heat's going to go from the surroundings into the system. So if you just grab some ice cubes and throw them on the table, okay, or on a countertop, obviously you know over time they're going to melt. Well, that is an endothermic process because heat is flowing out of the countertop and into the ice cubes. All right, so over time they're going to melt. They're part of the system, so their temperature is going to go up. Okay, and the surrounding temperature will get colder because heat's leaving the surroundings. All right, so overall, again, you don't quite have to write this down yet. In an endothermic reaction, the system will absorb energy. It'll feel cold to the touch because you're part of the surroundings. And heat is a reactant. We haven't defined what this is, but don't worry about that. Basically, this just means that you have to put heat into the system. So heat's present at the beginning for the reaction to occur. All right. For an exothermic reaction, the system's going to release energy. It'll feel warm to the touch because you're part of the surroundings. So heat's going into you as the observer. And heat is going to be treated as a product. So heat will be produced as a result of that reaction. Okay, so here's the actual chart you need to fill in, kind of the take-home points that you really need to know for being successful today on your scenarios. So just go ahead and pause the video for a moment and make sure that you write down each of these in the chart on page 13. Okay, so once you've had a chance to write all these things down, then I'd like you to turn back to page 11 in your packet. Cross out the warm-up at the top. We're not going to worry about that since we've already beat that to death. But I'd like you to read each scenario on page 11 and page 12 and take note of the system and the surroundings. That's defined for you for each scenario. All right, explicitly tells you which thing is the system and which thing is the surroundings. So what I'd like you to do, once you understand the scenario and the system and surroundings, is answer questions 3 through 7. All right, for each scenario on your own by yourself. All right, use the chart that you just filled out to help you. And once you think you've got your answers, then compare your answers to a classmate. Find a friend, discuss. See if y'all got the same answers, or if you're different, then try to decide who was right or wrong. And then after everybody's had a chance to do this for about 15 minutes or so, then be prepared to share your answers with the class. All right. There isn't a homework assignment tonight. Tonight is a designated no homework night. But remember, today I do need to get your labs, your lauric acid labs. Those need to be completed and turned in up at the front of the room if you haven't taken care of that yet. So thanks for watching. Like my videos, okay? Don't hate on me. And I will see you next time.